This is your AP Statistics Unit 1 study guide for the test on Friday. So we'll go over the main ideas of what we discussed this unit, and then I will review the top 5 missed College Board questions that you guys went through. So first, let's fill out this study guide. So we learned about variables, right? And we had 2 types of variables. What do you think those 2 types were? All right, I hope you said categorical and quantitative. Categorical would be if the sample data was a category or a type, a word. Quantitative would be if the data was a number, like how old you are, how many siblings you have, that kind of thing. Categorical would be what type of pet do you own? Do you have a dog, a cat? All right, from quantitative, we could break it down even more into 2 different categories. Do you remember what those 2 categories of quantitative variables were? Discrete and continuous. Discrete, typically within this class, is going to be if you have to have your data in units of whole numbers. Like if you're counting the number of people, or if you're counting the number of animals, that kind of thing. Continuous would be units that that don't have to be a certain specific whole number. Like height, you could say you're 5 foot 4 inches if you're short like me. But continuous, you can go in between whole numbers. All right, measures of center and measures of spread. All right, what were the 2 main measures of center that we talked about? Hope you see mean and median. Mean is the arithmetic average. So to calculate it, you would add up all the numbers, sum of sample data, divided by n, your sample size. So if you have 10 numbers, you'd add them up and then divide by 10. Median is your middle number. If your n is odd, then you have 1 middle number. I'll use the hashtag for number. If your n is even, you average the 2 middle numbers. I'll use the hashtag again because I'm running out of room. Remember, if you have a data set, you can just enter the data set into your calculator, and let me put it right here. You hit stat, and then enter, and then put your data in L1. Once you've done that, hit stat again, move over to the calc menu on the right, and then hit enter on the very first option, 1 variable stats. That gives you everything. It gives you the mean, the median, the Q1, the Q2, the max and the min, all that good stuff. So don't forget about that because you'll have your calculator on the AP exam and on this exam. All right, which one, and I'm going to use the statistical words, which one is resistant to outliers? Remember what that word resistant means. Which one's resistant, the mean or the median? All right, I hope you said the median. The median is resistant. The mean is not resistant. If you're not resistant, that means outliers affect you. So the mean gets skewed in the direction of the outliers. All right. Can you remember our 4 measures of spread or variability? These words are interchangeable. They mean the same thing. All right. I hope you said range, IQR, standard deviation, and variance. All right, range is your max minus your min. IQR is your Q3 minus your Q1. Your standard deviation is the square root of the variance, and your variance is the standard deviation squared. Remember, we were able to calculate these by the sum of the squared variance, right? You won't need to calculate them on the AP exam. You'll just need to recognize when it's being calculated. So like you would see the sum of the squared variances when you see the sample value minus mean being squared for every number in the data set. All right, which one of these four is resistant to outliers? There's only one of them. All right, I hope you said the IQR. The IQR is resistant to outliers. The rest of them are not resistant. That means outliers affect them. The range is affected by outliers, so it's the standard deviation and the variance. All right. So we found different ways to display one variable data. With the categorical data, we had two types of graphs. Do you remember what they were? All right, I hope you said frequency chart or plot, frequency chart, and relative frequency. All right, which one of these two shows the count only? Not the percentage or the proportion, but just the count of the data. All right, I hope you said frequency. Relative frequency shows the proportion or the percentage of the data. And it looks like a bar, a bar chart, except on the y-axis you either have frequency or relative frequency. So it's important to know which one you have because that affects your numbers. All right, now quantitative data. What were the different ways we could display quantitative data? We had at least 4 different ways, right? We had number 1, dot plots. Number 2, histograms. Number 3, stem plots or stem and leaf plots. And number 4, box plots. All right, 2 of these do not give us the underlying data. Which 2 are we not able to see the data set? All right, I hope you said histograms and box plots. We cannot see the underlying data with the histograms or the box plots. We can with the dot and the stem and the leaf. So with histograms, it gives us just intervals of ranges and we can see the count. Remember, box plots have the 5-number summary. The 5-number summary is your min, and I'll write this over here, your min, your Q1, your median, your Q3, and your max. If I were to actually draw it, you would be able to tell me what percent of the data is within each section. So I have 4 different sections, and 25% of the data is within each section. All right. All right, identifying outliers. I have a low outlier test and a high outlier test, right? And I've got 2 different kinds. I've got the IQR and the standard deviation. So for the IQR, the low outlier test would be the Q1 minus 1.5 times the IQR. The standard deviation test would be your mean minus 2 times the standard deviation. So that's to calculate low outliers. To calculate high outliers is the opposite. Q3 plus 1.5 times the IQR. And then X bar plus 2 times the standard deviation. Whatever number you get for these tests is not the outlier, it's the threshold for the outlier. So any number in your data set below the lot is an outlier. Any number above the hot is an outlier. So this just helps you identify the outliers. All right, shapes of distributions. Go ahead and tell me, what is this shape? All right, I hope you selected symmetric. I draw a line down the middle, and it's about roughly the same on either side. What about this one? All right, I hope you said skewed right. Remember, it's skewed in the direction of the tail, and the tail is to the right, which makes this one skewed left because the tail is to the left. All right, so with this one, tell me which one would be greater, the mean or the median? All right, for here, I hope you said the mean would be greater than the median because the skew is pulling the mean over. So the mean is going to be greater. And then it's the opposite over here. The median's going to be greater because the skew is pulling the mean to the lower numbers. All right, what type of distribution is this? I hope you said uniform. They're all about roughly the same. And then this right here has two distinct peaks in the data. It's bimodal. All right, whenever you are asked to describe distributions, there's four things you need to talk about. What should you talk about? Sockov. Shape, outliers, center, and variability. All right, shape, you've got your options up here, the shape of the distributions. The outliers, you would perform the outlier test. The center, you would mention the mean or the median, whatever is easier to calculate. And for the variability, you would mention the range, the IQR, the standard deviation, or the variance, whatever is easiest to get. And remember, you only need to mention one. You don't need to mention both the mean and the median, just pick one. You don't need to mention all four of these, you just pick one. When you're comparing two distributions, you need to mention the shape and the outliers for both the distributions. And then for the center and the variability, you need to use comparing words. Like greater than, less than, or approximately equal to. All right. And then we spent our last couple of packets doing the normal distributions. So properties of normal distributions that we learned about. We know they're symmetric and they're bell-shaped, and that the mean is equal to the median because of that, because it's symmetric and bell-shaped. So the mean and the median are the same thing. It's at the top of that peak. We also did the empirical rule. So we know that 68% of the data lies within one standard deviation, 95 is within 2, and 99.7 is within 3. And you calculated the area of each section. You also learned how to calculate a z-score. Remember, the z-score formula is value minus mean over standard deviation. And you remember, or you know what a z-score is, right? A z-score is something specific. It's not just a random number. It is the number of standard deviations above or below the mean of a specific value. So whatever value you plugged into the z-score formula, when you got the z-score, that's the number of standard deviations above or below that mean that the value is. So if it's positive, it's above. If it's negative, it's below. We also learned last class how to use the table A. So we haven't gotten between two values yet, so you're going to ignore that. That won't be on the test. But we did have lower than a value and higher than a value, right? So lower than a value, you calculate the z-score. This is if you're shading to the left. Let me put that here. If you're shading to the left of a number, you're going to calculate the z-score. And then you're going to use that z-score to look up the table A value, and that's your answer. If you're shading to the right, there's just one extra step. You calculate the z-score. You look up the table A value. And the table A value gives you the area to the left of a certain number, right? So if I want the area to the right, I'm going to subtract it from 1. So I'm going to do 1 minus the table A value. And that's going to give me my answer. 1 minus the table A value, and that's my final answer. All right, let me go ahead and pull the top 5 missed questions on the progress check, and we'll go over those. Okay, so here are your top 5 missed questions. I pulled 3 from the first multiple choice and 2 from the second. All right, so looking at this, it says data are collected on 35 students in a college history course. Which of the following is not a variable? So remember, variable is information you're collecting about the students. So birth month, political affiliation, student age, student address, number of students in the data set. That's not a variable, that's our sample size. So this is the correct answer. This is in the sample size. All right, up here, do you think this is categorical or quantitative? Categorical. Political affiliation? Categorical. Age? Quantitative. Address? Categorical. I can't take an average of an address. That wouldn't mean anything to me. All right, next up. The relative frequency table shows the reasons given by high school students for their last absence from school. Which of the following is not supported by the relative frequency table? All right, so number 1, so that means A, B, C, and E are true. Let's make sure they're true. More than half of the students were absent because of illness. All right, so it's in relative frequency. So more than half would be more than 50% or more than 0.5. Is that true? It is, because it's 5.7, so this is true. 0.57, I'm sorry. More than 1/3 of students were absent because of oversleeping or college visits. So let's see what 1/3 would be as a decimal. All right, so it's got to be more than 0.33 repeating. So let's see. We said college visits, which is 0.16, plus oversleeping, 0.2. 0.16 plus 0.2 is 0.36, which is greater than 0.33, so this is also true. All right, the reason given the least number of times was they did not finish the assignment. So that's got to be the smallest proportion. So did not finish the assignment is the smallest proportion, so that's true as well. And then let's look at E. Less than 1/4 of the students were absent because they overslept. So 1/4 would be, as a proportion, 0.25. So it's got to be less than 0.25. So oversleeping is 0.2, which we know is less than 0.25, so that's true as well. Why is D false? D has an actual frequency, not a relative frequency. I have no idea what the sample size is. I just have the relative frequency, like the percentage of students. I don't know if this is 100 students. I don't know if this is 1,000 students. It doesn't tell me. So I have no idea what the count is. So since this is talking about frequency, it's not supported by the table. So D is your correct answer. All right. And this is the last one from the first multiple choice set. So a group of middle school students were asked what school subject was their favorite, and they are displayed below. So this says number of students. So is this a frequency chart or a relative frequency chart? All right, I hope you said frequency because it's number of students, not proportion, right? Which of the following is supported by the bar chart? All right, A is my correct answer, so A is supported, so that means B through E must be wrong. So let's see why these are wrong. For students who choose social studies, the number of grade 8 students was at least 100% greater than the number of grade 7. So it's doubling the number of grade 7. So we're looking at social studies. So it doesn't look like grade 8 is twice as much, right? It would have to be a whole nother bar. It'd have to go to about here to make a whole nother bar. 100% greater would be a whole nother bar, twice as much. So that's not right. All right, for students who chose science, the number of grade 8 students was at least 50% less than the number of grade 7. All right, so science, number of grade 8 was 50% less. Does that look like half? It definitely does not. All right, for students who chose math, the number of grade 8 was at least 50% less than the number of grade 7. Again, this doesn't look like half of that. 50% is half. For students who chose language arts, the number of grade 8 was at least 100%, so double the number, greater than grade 7. So language arts. This grade 8 does not look like twice as much as the grade 7. 100% would be a whole nother 25, so it would have to go out to 50. This part would have to go out to 50, and it doesn't. All right, so none of those are correct. Let's look at A. For students who chose art, the number of grade 8 students was at least 100% greater than the number of grade 7. So 100% is doubling the grade 7 numbers. So let's look. The grade 7 numbers look to be about 8. So doubling that would be 16. It's well over 16. 16 might be about here. So A is your correct answer. All right, I picked 2 from the second multiple choice. All right, so this one's about a box plot. Which of the following statements is supported by the box plot? Well, A, we can eliminate because the box plot doesn't tell us about the mean. So we don't know anything about the mean. We only know about the median from the box plot. B says the number of people with a height of at least 70. So 70 is our Q3. So at least 70, so it'd be 70 or greater. Oops, I'm sorry. The number of people with a height of at least 70 is greater than the number of people with height at most 62. So at most 62 would be below. Remember, this is 25% and this is 25%. So they're exactly equal. It's this whisker and this whisker. So with people who have at least 70 or above is 25% of the data. At most 62, meaning 62 or below. So they're exactly the same. They're both 25% of the data. So that's not true. All right, C, the number of people with a height at least 67 inches. So if at least 67 is the median. So if you have at least 67, that's 50% of the data. So anything bigger than 67 is 50%. Is less than the number of people who have at most 67. Nope, again, those two are equal. They're both 50% of the data. Anything above 67 is 50%, anything below 67 is 50%. So this is not supported. All right, E, the last one that's untrue, says approximately 25% of people have a height greater than 62. So here's 62. Anything greater than that, from the Q1 to the max, is going to be 75%. So E would be true if it said 75%, but it doesn't. It says 25, so that's wrong as well. And our correct answer, approximately 50% of people have a height between 62 and 70. 62 and 70 are the Q1 and the Q3, and we know that 50% of the data falls there, right? I have 25% here and 25% here. So 50% falls between the Q1 and the Q3. So D is correct. All right, and the last one. The following table shows summary statistics in thousands for number of electrical workers. All right, based on the 1.5 times IQR rule for outliers, which of the following is a correct comparison of the two distributions? All right, so now I know that I don't have to use this rule, so I need the first and third quartile, the Q1 and the Q3. All right, so let's go ahead and calculate the electrical hot and lot. Electrical. All right, I have my Q1 is equal to 278. My Q3 is equal to 320. So I can go ahead and calculate the IQR. Remember, that's the Q3 minus the Q1. So 320 minus 278. 42. All right, let's go ahead and pull the data for concrete, the other data set. Concrete, my Q1 is 262. My Q3 is 308. So now I can use that to calculate my IQR. 308 minus 262 is 46. All right, let's do my hot and my lot. Let me look back at that study guide that we already filled out. My outlier test, Q1 minus 1.5 times the IQR, Q3 plus 1.5 times the IQR. All right, so I got 278 minus 1.5 times 42. My hot's going to be 320 plus 1.5 times 42. All right, let's see what I get with these two numbers. You go to Desmos because it's easier. All right, 278 minus 1.5 times 42. All right, I get 215 for the lot. All right, for the hot, I'm just going to change those first two numbers. 320 plus. All right, so I get 383. Let me draw a line between these. All right, let's do the lot and the hot for the concrete while we're at it. So the lot would be 262 minus 1.5 times 46. I just substituted out the new Q1 and the new IQR. And the hot is going to be 308 plus 1.5 times 46. We're going to plug these into Desmos. All right, so 262 minus 1.5 times, so 193 is my lot. 377 is my hot. All right, so now that I got my thresholds, I can figure out what outliers I have by looking at the minimum and the maximum. All right, so my minimum is 239. My minimum is 239. Do I have any low outliers? No. No low outliers. All right, my maximum for electrical is 330. My high outlier threshold was 383. So do I have anything above 383? I do not. So I have no high outliers. All right, for my concrete, my minimum, my concrete, my minimum is 186 and my maximum is 335. I'm just pulling them straight from the table. So now I can use my low outlier threshold. Look, my minimum is less than my low outlier threshold. At least one potential outlier, or at least one outlier, one low outlier. I know the minimum at least has to be an outlier. There could be more. There might be more numbers between these two. And my maximum is 377. I'm sorry, my max is 335. That doesn't get above the high outlier, so I've got no high outliers. All right, so electrical has none. Concrete has at least one low. So let's go back and look at these. This says they both have high outliers. Nope, none of them have high outliers. This says they both have low outliers. That's not true either. This says they don't have outliers at all. That's not true. And then E says the concrete distribution has at least one high outlier and the electrical has no high outliers. Again, that's not true because they have no high outliers. So D is our correct answer. D says concrete has at least one low outlier. We agree with that. And the electrical has no lower outliers. We agree with that. That's why D is correct. All right, good luck studying. I'm available on Remind and email if you have any questions, and I'll see you Friday.